For you today on Step by Step Kinematics, so moving stuff. Before lifting off, however, one or two tips. If you are not a master of vectors, go and binge on my videos about vectors. Otherwise, in a couple of minutes, you will be like, I don't get it. Second, subscribe now and maybe tip me. Let's start! I know you're just waiting for speed equals space over time, acceleration, and other stuff you have read on fortune cookies. But hold on a second. When dealing with moving stuff, your first duty is to choose a frame of reference. It's literally gonna rain vectors in a few moments, so it's a great idea to set a positive and a negative direction in your system, so you can give these vectors a sign. Like, my grandpa wakes up on Sunday morning in Milan. He admires the Madonnina, takes his sport car and goes to pick up wild mushrooms in the woods of northern Italy. In this story, I can choose my frame of reference so that every movement from grandpa's house to his destination is positive, and therefore those from Mushroomland to Milan are negative. This is not mandatory. I made this choice because I like it this way. But I could also do the opposite and it would be fine. From now on, every vector heading from Milan to the wood is gonna be positive, and those from the wood to Milan are gonna be negative. This is crucial so we don't mess up later. But there's more! A frame of reference is not just about choosing signs. You must also choose a point of reference. This will be the point you're gonna measure all distances from. My grandpa's point of reference is gonna be Milan. I mean, it doesn't make much sense to measure distances from a random service station on the way, right? So, sign for vectors and point of reference for distances. Now, I could just give you all the equations and leave you in agony, but you would understand them like I would understand a Korean recipe. So, I have to tell you first what these letters mean. You see, there's a basic set of quantities that you can combine to build as many formulas as you want. The first quantity is time, which I will write as t from now on. But now comes the fun. Ladies and gentlemen, the trio position, displacement, and distance. Matteo, but aren't they like all the same? Look, go tell an Italian that pizza al taglio, pizza napoletana, and pinza romana are the same thing. You just won a one-way ticket to hell. Position is a vector, so it's an arrow which connects the point in space you're standing on and the point of reference. If Grandpa is going to his mushroom hunting spot, this is his position at this precise moment, 30 kilometers from Milan towards the wood. Displacement is still a vector, but it connects the starting point and the ending point. Also, I better just tell you right away that distance is not a vector, it's a scalar, so it's a number. Its job is telling you how long you've traveled. Let's say Milan and the wood are 50 kilometers away. When Grandpa reaches his destination, his displacement is gonna be this guy here, a 50 kilometers module vector pointing towards Mushroom Town. The distance traveled is also 50 kilometers. Matteo, but you just said they were different! Yeah, wait a second. Let's say Grandpa is done with his porcini hunt session and is coming back home. He has to drive for another 50 kilometers. So, it's a total of 100 kilometer trip. But his displacement at the end of the day is not 100, is 0. That's because his final position and his starting position are the same. So, displacement and distance are not the same thing. I'll also show you a nice trick. Displacement can be calculated as the difference between the final position and the initial position. And yes, displacement is written with this weird symbol called delta. So this must be read delta S. Don't think of them as two separate quantities, it's a single block. In physics, the delta symbol indicates a difference between a final quantity and an initial quantity. That's why displacement is final position minus initial position. But let's move on to tonight VIP. speed. And I have bad news for you. There's not such thing as just speed. There are 3 different quantities written as v. I know that in your head there's this voice saying speed equals space over time, but in physics, space doesn't mean anything. A few seconds ago, you saw that there are different ways of talking about space. If as space you mean displacement, then you have velocity, which is displacement divided by time interval delta t. Velocity is a vector because it is calculated with displacement, which is a vector. If you use distance instead, you get speed, distance over time interval delta t. Speed is not a vector, it's just a number. Neither of those is better, you can use whichever one you want depending on the situation. And then there's the third guy. The third one is the instantaneous velocity. It's called instantaneous because it's not calculated over a period of time. It's your velocity at a precise moment in time. If Grandpa is flying back home on the highway because he has to put mushrooms in the refrigerator, the value shown by the car speedometer is his instantaneous velocity. I'll tell you about instantaneous velocity, dirty little secrets, later in the second part of the video, but for the moment just remember that it's a vector, and you're gonna be fine. Okay, so your set of motion quantity is complete. We can start building some equations. This is the easy one. That's when you move at a constant speed in a straight line, like my grandpa when he goes 90 miles per hour on the highway. Formula for uniform linear motion. Final position equals initial position plus velocity times time. This stuff is your law of motion, and it's telling you your position as a function of time. I want an example with Grandpa. Oh fuck yeah. Grandpa leaves Milan and drives at 50 miles per hour. Let's use law of motion to know where he's gonna be in half an hour. Grandpa's starting point is 0 because he started his journey from home. Speed is 50 miles per hour. Time is half an hour, so his position after 30 minutes is 25 miles from Milan, so about 40 kilometers. But now let's see another scenario. Grandpa decided to stop at the service station for a quick espresso and then he goes back on the street. The service station is 10 kilometers away from Milan. Now we want to know where he is half an hour after leaving the service station. You have to be very careful here because you have to take into account that Grandpa is not starting from the point of reference, so Milan, but from the service station. He already has some road behind his back. SI is not 0 now, because Grandpa's starting point is 10 kilometers. So, after 30 minutes from the service station, Grandpa is 50 kilometers from home. And now, let's take this to another level. Let's say Grandpa called me on Saturday night and told me, "Look, my boy, tomorrow morning I leave at 6 o'clock. The next day, however, Grandpa doesn't leave at 6, but at 6:30, because he did some push-ups and lost the track of time. But I still think he left at 6. If someone asked me at 8, how far is Grandpa now? I would think he has been on the road for 2 hours, but he is actually half an hour late. In order to take this delay into account, we needed to tweak the equation of motion adding minus t0 here. T0 is actually the delay. With this delay, Grandpa traveled from 1 hour and a half and scored 120 kilometers. Matteo, but which speed or velocity or whatever is this v here? You said there are 3. Which one should I use? Hey, this is uniform linear motion. They are all the same. If you're keeping the same speed at all time, there's no difference between them. So, take it easy. But what about accelerated motion and the instantaneous speed and everything else? For those, rush to the second part of the video. You can also find the link in the description below. Remember, you can support this channel with a tip. This project stays alive with your support. If you find my lessons useful, you can offer me the equivalent of a drink and actually make a difference. Also, remember to subscribe, leave a like, tell all your classmates and friends to watch the video, and come on, see you next time. Ciao!